In the autumn of 1989, a young engineer walked out of Building 707 at the Rocky Flats plant outside Denver, Colorado, and did not go back to work the next day. He had spent 3 years inside that building, machining plutonium into the hollow, grapefruit-sized spheres that formed the trigger of a thermonuclear weapon. He had signed papers promising never to describe what he did there. Years later, in an oral history collected for a Colorado Public Health Archive, he described the moment differently than the government ever did. He did not call a shutdown. He called it the day the country finally asked what happens to a bomb factory when nobody needs the bombs anymore. This is not a story about the weapons themselves. The weapons are the part everyone already knows, the mushroom clouds, the arsenals, the countdown clocks of the Cold War. This is a story about what was left over. Between 1944 and 1994, the United States produced roughly 99.5 metric tons of plutonium for its nuclear arsenal, enough for an estimated 70,000 weapons across the life of the program. It also produced hundreds of tons of highly enriched uranium. When the Cold War ended and the arsenal shrank by nearly 80%, that material did not disappear. It sat in vaults, in bunkers, in leaking barrels behind chain-link fences in Colorado, Texas, Washington State, and South Carolina. Enough fissile material, undiluted, to build tens of thousands more weapons than the country would ever need again. This is the story of what the government did with the bomb-making material after it stopped wanting the bombs. Not the monuments. Not the museum exhibits with the mannequins in radiation suits. The paper trail, the memos, the reclassification orders, the failed billion-dollar facilities, and the raid conducted by one federal agency against another. To understand why this became a crisis rather than a footnote, you have to understand what American planners assumed going into it. Through the 1970s and 1980s, the nuclear weapons complex operated on a simple internal logic. Material flows in, weapons flow out, and whatever plutonium is recovered from scrap, lathe turnings, or obsolete warhead components gets fed back into the machine, because producing new plutonium from scratch is expensive and producing it from recycled stock is comparatively cheap. Rocky Flats, the plant 14 miles northwest of Denver, existed almost entirely for this purpose. Operated first by Dow Chemical and then by Rockwell International under contract to the Department of Energy, it manufactured plutonium pits at a rate of 1 to 2,000 a year and served, from 1964 onward, as the sole domestic source of the plutonium trigger for the entire American arsenal. The planner's internal taxonomy was straightforward. This was a production facility, not a storage facility, and certainly not a waste site. Everything on the property was, by definition, a resource in transit toward a weapon. That assumption held for nearly 4 decades. Then, beginning quietly in the mid-1980s, a different kind of paperwork started arriving at the Environmental Protection Agency and, eventually, the FBI. Plant insiders, men and women who had watched barrels of plutonium-contaminated oil corrode and leak into the soil since the 1950s, who had seen an incinerator burn waste in violation of its own permit late into the night, began quietly informing federal investigators that Rocky Flats was not merely producing weapons. It was accumulating an uncounted, uncontained surplus of hazardous and radioactive material that nobody upstream had planned for. In December of 1988, FBI agents began flying light aircraft over the site at night, using infrared cameras to confirm that the supposedly shuttered incinerator in Building 771 was still running. A former employee named Jim Stone had already handed investigators a 1986 internal memo describing the plant's waste practices as, in the government's own words, patently illegal. It did not match the internal model. The taxonomy was wrong. Something whose sole institutional purpose was weapons production had, without anyone formally deciding it, become one of the most contaminated industrial sites in North America. And nobody in Washington had a category for what to do about that. The mechanism behind the crisis was not sabotage or incompetence in the cartoonish sense. It was structural. For the entire Cold War, the nuclear weapons complex was organized around a doctrine of continuous forward production. Build, stockpile, deter. There was no institutional mechanism, no office, No budget line, no accepted engineering standard for the reverse process of taking fissile material out of the system permanently. Arms control analysts who studied the aftermath later described this as a one-way pipeline problem. The entire infrastructure of the Manhattan Project and its Cold War successors was engineered to move uranium and plutonium in a single direction, from or to weapon. Nobody had engineered the pipe to run backward. When the geopolitical logic of the Cold War collapsed faster than the physical infrastructure could adapt, the country was left holding tens of tons of material that was, in the precise technical sense used by the Department of Energy, access to national security needs, a phrase that sounds bureaucratic and understates, almost comically, the fact that it described enough weapons-grade material for tens of thousands of bombs with nowhere sanctioned to go. The first case study in this pattern is Rocky Flats itself, and it plays out over 3 weeks in June of 1989. At 9 o'clock in the morning on June 6th, more than 70 FBI and EPA agents arrived at the plant under the pretense of briefing staff on a domestic terrorism threat. It was, by multiple later accounts, the first time in American history that one federal agency raided another. Rockwell's on-site manager, Dominic Sanchini, was served a search warrant instead of a briefing. Investigators later testified that as agents worked through the site, plant personnel physically moved barrels of hazardous waste out of rooms scheduled for inspection, then returned them once the agents had left. A Rockwell manager, confronted with a stack of documents describing environmental violations, told investigators they were personal diary entries from an earlier NASA job. They were, in fact, records of the plant's own illegal practices. By the time the raid concluded, agents had found 62 pounds of loose plutonium residue trapped inside the ventilation ductwork of the incinerator building alone. Plutonium that had, in effect, been drifting through the plant's own air handling system for years, invisible to any official inventory. A Colorado grand jury was convened, one of the first special grand juries in the state's history. Over 4 years, it reviewed roughly 2,000 exhibits and heard testimony from 110 witnesses. It found what its own foreman later described, in a book written after the fact, as an ongoing criminal enterprise involving both the contractor and the Department of Energy itself. No individual was ever indicted. Rockwell pleaded guilty to 10 federal environmental crimes and paid an $18.5 million fine, at the time the largest environmental penalty in American history, and, according to a later government audit, still less than the company had been paid in performance bonuses for running the plant. Production at Rocky Flats halted that December and never resumed. Over the previous 4 decades, investigators estimated, the facility had lost track of more than 2,600 pounds of plutonium and other radioactive material. Not stolen, not diverted for weapons, simply unaccounted for inside a production system that had never been designed to keep a closing inventory. One retired special agent who led the investigation put it plainly, years afterward, in an open letter to Congress. He had been ordered to conceal parts of what his own investigation had found. The case that was supposed to be about illegal incineration had become, almost by accident, the first public proof that the government's fissile material accounting had a hole in it large enough to lose kilograms of bomb-grade plutonium and not notice for years. If Rocky Flats was where the country discovered it had a leftover material problem at the scale of a single plant, the second case study shows what happened when the same problem appeared at the scale of an entire former superpower's arsenal, and produced an outcome that ran directly against the logic of 40 years of Cold War planning. By 1991, the Soviet Union had ceased to exist, and the newly formed Russian Federation held an estimated 500 metric tons of highly enriched uranium, drawn from thousands of warheads, sitting in facilities that American officials who visited them described as barely secured, buildings that were not even marked on maps, guarded in some cases by little more than a padlock and a board conscript. Conventional Cold War logic said this material was an adversary's strategic asset, to be watched, contained, and if possible denied. What actually happened was the opposite. In February of 1993, the American and Russian governments signed an agreement to convert 500 metric tons of Russian warhead-grade uranium, material that, months earlier, had been aimed at American cities, into low-enriched fuel for American commercial power reactors. It became known informally as megatons to megawatts. The first shipment of converted fuel reached the United States in 1995. Under the terms of the deal, Russian technicians blended down the 90% enriched bomb material with natural uranium inside Russian facilities, producing reactor-grade fuel at roughly 4 to 5% enrichment, which was then shipped to Kentucky and Tennessee for processing into commercial fuel assemblies. By the time the program formally concluded in December of 2013, it had converted 500 metric tons of weapons-grade uranium, the fissile core of some 20,000 nuclear warheads, into more than 14,000 metric tons of reactor fuel. For 2 full decades, roughly 1 out of every 10 kilowatt-hours of electricity consumed in the United States had, at some point in its supply chain, been part of a Soviet nuclear weapon. A Russian non-proliferation analyst who studied the deal called it, in later interviews, the only instance in history where disarmament turned a profit. Russia ultimately earned an estimated $17 billion from the arrangement. No Cold War planner in either country had modeled that outcome. The material that was supposed to represent the gravest threat the two nations posed to each other instead became, quietly, part of the machinery that kept American lights on. The third case study is the largest in scale, the most expensive in cost, and the one where the government's plans came closest to complete public failure. And it concerns not uranium, but plutonium, which cannot simply be diluted the way uranium can. Weapons-grade plutonium blended with other material remains, chemically still plutonium. There is no equivalent of downblending that renders it permanently unusable in a weapon without either burning it as reactor fuel or burying it. In 1998, the United States and Russia each declared 50 metric tons of plutonium surplus to military needs. And in September of 2000, the two governments signed the Plutonium Management and Disposition Agreement, committing to eliminate a combined 34 metric tons, enough combined for an estimated 17,000 weapons. The American plan centered on a single facility, the mixed oxide fuel fabrication facility at the Savannah River site in South Carolina, designed to blend surplus weapons plutonium with uranium into MOX fuel for use in ordinary commercial reactors, at a planned processing rate of 3.5 tons of plutonium a year. Construction began in 2007. The facility was supposed to be operating by then at a projected cost of roughly $1 billion. It was still under construction a decade later. By the time the Department of Energy finally canceled the project in 2018, cost estimates for completing it had climbed as high as $30 to $50 billion, a hundred-fold escalation from the plant's original budget, and the facility had produced not 1 gram of usable fuel. There is a particular kind of failure in a weapons disposal program, an initiative built to prove that the two former Cold War adversaries could permanently retire their most dangerous material instead became, for the American side, a 2-decade demonstration of how difficult it is to build anything resembling that pipeline running backward. Senator Pete Domenici, reviewing the alternative disposal plans in a 2002 letter to the Secretary of Energy, wrote that he wanted assurance that weapons material would never be reduced to waste disposal standards through dilution alone rather than genuine elimination, a warning about exactly the substitute plan the government would eventually be forced to adopt. After the MOX plan's cancellation, the Department of Energy pivoted to a program called Dilute and Dispose, mixing the plutonium with inert material and burying it permanently, nearly 2,000 feet underground at the Waste Isolation Pilot Plant near Carlsbad, New Mexico, a facility originally built for far less dangerous, lower-level Cold War debris. Not 48 metric tons of weapons-grade plutonium. Russia's government objected publicly, arguing that diluted but buried plutonium remains, in principle, recoverable, unlike plutonium that has been irradiated into spent reactor fuel. Vladimir Putin's government cited the abandonment of the MOX program as one justification when Russia formally withdrew from the 2000 disposition agreement in October of 2025. What began as a joint promise between two former enemies to make their most catastrophic material unusable together ended a quarter century later as two separate, unfinished national burials. In the years after these programs ran their course, the men and women who had built and administered them began writing what amounted to an institutional confession, each from a slightly different angle. Matthew Bunn, a Harvard researcher who spent decades tracking the fissile material accounts of both countries, described the uranium deal as one of the greatest arms control achievements in history, and, in the same breath, noted that its success had depended on a set of political and economic conditions in 1990s Russia that no longer existed and likely never would again. Officials who had worked the plutonium disposition file were blunter about their own miscalculation. The 2015 Red Team review that led to the cancellation of the MOX plant found that Energy Department planners had, for nearly 2 decades, underestimated both the engineering difficulty and the political cost of building a first-of-its-kind facility to handle bomb-grade material, as if it were an ordinary industrial process. And the retired FBI agent who had led the Rocky Flats raid put his own reckoning most starkly of all, writing years later that the agency he served had ordered him to withhold from Congress and the public the full extent of what his investigation had uncovered inside America's own weapons complex. 3 different institutions, an arms control research community, an energy bureaucracy, and a federal law enforcement agency, arrived independently at versions of the same admission. The material itself had never been the hardest part of the Cold War to build. Getting rid of it safely, honestly and completely was. The engineer who walked out of Building 707 in 1989 gave a second interview more than 20 years later, after Rocky Flats had been demolished, its buildings reduced to slabs, and its grounds partially reopened as a wildlife refuge grazed by bison. In his first account, recorded not long after the raid, he had described his years inside the plant as a kind of quiet complicity, building the trigger for a weapon he hoped would never be used, and telling himself that not using it was the same as it never having existed. By the second interview, he corrected himself. It was not the same, he said. A bomb that is never detonated is not erased. It is inherited. The plutonium inside, it does not stop being plutonium because a war never came. Someone eventually has to decide what to do with it, and that decision, not the explosion that was avoided, is the part of the Cold War's ending that nobody had actually planned for. 60 years after the first weapons-grade plutonium came out of American reactors, tens of tons of it are still sitting in interim storage, waiting on a disposal program the country has restarted, canceled, and restarted again 3 times over. The bombs, in the end, were the easy part. They were built on purpose by people who understood exactly what they were making. What came after, the leftover material, inherited by people who had no hand in making it and no good plan for where it goes, has taken longer to resolve than the war that produced it, and, as of this year, still is not finished.